Okay, so question 18, definitely the hardest question that we had by far so far. Okay, so when you read through it, the important information to pull out is that when time is equal to 0, I is also equal to 0. And the other important information is that we are going to be proving that I is always going to be less than V divided by R. Okay, so first thing I'm going to do is I'm going to state by writing out what we've got. I'm going to rearrange it into what we want. Okay, so first thing I'm going to do, I'm going to move everything away from our derived expression part there. So this is going to come over and become V minus Ri. I'm going to take K across by dividing everything by K. And that's going to leave me with Di over dt. Now we can see that this expression over here has an I in it. And if I take the t across at the moment, then it's going to be trying to integrate with respect to t, and I don't have a t over there, so that's going to create a problem. So instead, I'm going to flip both of the fractions. Okay, and now when I take the di across and turn this into an integral question, now I've got something I can work with. So now I can state again what I've got. So t is going to be equal to, now I can take the k out the front, it's just a constant, 1 over v minus ri di. Now everything else in this expression gets treated like it's supposed to be a number. So you just kind of like ignore it, treat it like a number. The only thing in there that's really interesting is the I part. So when I integrate this, it's going to become, okay, if I derive the bottom of that, I'll be left with minus r. So minus r is coming to the bottom over here. ln bracket v minus ri, close bracket, plus c. Okay, so that's what my expression becomes. Now I need to use that initial piece of information to solve for t. So solve for c. So I'm going to let t equal 0 and I equals 0, and I'm going to solve for what I've got left. So 0 is equal to k over minus r ln v plus c. Now, c can come to the other side. This will just change that to a positive then. So k over r ln v, and that's what c is. So now my full expression is going to look like this. T equals k over minus r ln v minus ri plus k over r ln v. Okay, so now I'm going to, so I've stated my equation again. Now I'm just going to get it into a form that I prefer to work with, because at the moment it's looking very messy. So first thing I'm going to factorize out is the k over r. You can see that that would leave this term being the minus 1, which means that this is going to be the denominator of our fraction. So it'll become v over v minus ri. And that is what our equation will look like. So that gets me the time of this. Now, I haven't proven our statement yet. So I'm going to start rearranging things and just see what happens. So first thing I'm going to take over is the r and the k. So it'll become t r over k. Next thing that's going to come across is I'm going to take the ln. So it'll become e to the power of all of this is equal to v over v minus ri. Okay, so next important thing that I need to notice is that t is equal to 0 here. The whole thing is going to become still a positive number. It's just not going to become a negative number in this case, meaning that e tr over k is always going to be greater than 0. Okay, so if I can treat that like, yeah, this is the part where it gets a little skew-iffy, because there's a lot more, thought that goes into this last maybe 4 steps. Okay, so Next thing that I'm going to do, I'm going to flip both of my fractions to get this v minus ri on the top, and I'm going to move the v to the other side. So that if this became 1 over this, then it just means that to bring it back to the top, I just make that negative tr over k. This will become v minus ri over v. Take the v over, whee. That means now I can get rid of it on the bottom here, and that's what I'm left with. Now, using this statement from above, I'm going to say that 0 then is always going to be greater than v minus ri. Okay, which really means that if I take the v to the other side, it's going to flip my little symbol there, ri, like that. And if I take the r over, it's going to decrease it even further. So once I've done that, I can state, therefore, true. Now, like I said, this last part, a little bit harder to comprehend, but when you start to substitute values in and you start experimenting with it, you can see that it's true. I don't have a faster way of doing it for an exam, though.